Welcome to the Greek Ship Corrosion channel. My name is Maryam Ehteshamzadeh. I'm a researcher in the field of corrosion and protection of materials. Chapter 8, Section 2, Electrochemical Impedance Spectroscopy. Basic concepts in EIS technique, angular frequency corrosion equivalent circuit, and electrical circuit elements are discussed in this video. Basic concepts in EIS technique. This method for evaluating the corrosion rate and mechanism is based on measurement of alternating current impedance over a range of applied frequencies. A sinusoidal wave signal is a type of periodic signal that oscillates, moves up and down periodically. In the EIS method, potentials are applied over the frequency range of 10 raised to 5 to 10 raised to -3 Hz in order to provide full information on the corrosion process and cell performance. Corrosion equivalent circuit. Corrosion equivalent circuits are models used to represent the electrochemical behavior of corrosion processes through an assembly of circuit elements. These circuits are designed to create the same impedance spectrum as the real system, allowing for analysis and interpretation of electrochemical impedance spectroscopy data. Common circuit elements used in modeling corrosion processes include resistors, capacitors, and sometimes inductors. These components are integral for simulating electrical properties like current flow, energy storage, and the overall behavior of the corrosion process. Sinusoidal wave signal. A sinusoidal signal can indeed start at a point other than zero time. The time delay or the duration after which the sinusoidal wave begins is expressed as a phase difference, represented by the symbol phi. This phase difference is typically measured in degrees or radians. The phase angle refers to the angular displacement of a sinusoidal wave from a reference point in time. Is a characteristic of periodic waves and is often represented in electrical circuit as the phase difference between voltage and current. This is the voltage wave and this is the current wave in this figure, and phi is equal to 30 degrees. Omega times t equals 2 times pi number. Angular frequency. Angular frequency, symbol omega, also known as angular speed or angular rate, quantifies how fast an object rotates or oscillates in terms of the angle described per unit of time. Omega in radians per second is equal to 2 times pi over t equals 2 times pi times f. F is in hertz. It is measured in radians per second and is equivalent to angular velocity in circular motion. How much is a radian? A radian is a unit of angle measurement in the International System of Units, SI. 1 radian is the angle subtended at the center of a circle by an arc that is equal in length with the radius. 1 radian is equivalent to approximately 57.3 degrees. Pi radians is equal to 180 degrees. Arc length equals radius r. This is 1 radian. What is the RLC electrical circuit? RLC circuit is an electrical circuit consisting of a resistor, an inductor, and a capacitor connected in series or in parallel. One of the most important tools for analysis of RLC circuits in the presence of alternating voltage or current is phasor. Phasor is introduced in the video titled number E26, Chapter 8, Section 3. Electrical elements. Resistors are primarily divided into 2 types, linear and non-linear. Linear are divided into 2 types, time invariant, time variant. And non-linear resistors are divided into 2 types, time invariant and time invariant. For modeling of a corrosion process, linear and time invariant type is used. Linear resistors have a constant resistance value, while nonlinear resistors have resistance that changes with voltage or current. The characteristic curve of a resistor representing the relationship between voltage and current is a straight line. This linear relationship is encapsulated in Ohm's law, which states that V is equal to I times R, where I is the current and R is the resistance. By measuring pairs of voltage and current values, we can plot this linear curve for the resistor, confirming its consistent behavior under varying electrical conditions. Capacitor. Capacitors are primarily divided into two types: linear and nonlinear. Each one is divided into two types: time invariant, time variant. The characteristic curve of a capacitor typically describes its relationship between voltage and charge. What's a constant phase element? A constant phase element, CPE, is often used to replace the double-layer capacitance in electrochemical impedance spectroscopy analysis. A random circuit may consist of an active electrolyte resistance Rs in series with the power combination of the double-layer capacitance and an impedance ZW of a Faradic reaction. Faradic reaction is the topic of the video number E24. Here, a CPE is used to replace the double-layer capacitance. A constant phase element is an electrical circuit component used to model the behavior of systems such as electrochemical interfaces, particularly at solid electrodes. It exhibits a phase angle that remains constant regardless of frequency, making it distinct from conventional capacitors and resistors. This characteristic allows it to effectively represent the effects of an imperfect double layer in electrochemical systems. Inductor. Inductors are divided into two types: linear, nonlinear. Also time invariant, time variant. Time invariant, time variant. The characteristic curve of an inductor typically shows the relationship between the inductance and the current, as well as the inductor's reactance based on frequency. In the inductors, V is equal to L times differential of the current over the differential of the time. V is the voltage, L is the inductance, I is the current, and T is time. Inductance is a property of an electrical circuit that reflects how much voltage is induced in response to a change in current. The higher the inductance, the more it opposes changes in current flow. In the context of inductance, phi typically refers to the magnetic flux. Inductance L is defined as the ratio of the magnetic flux phi produced by a current I flowing through an inductor to that current itself, expressed mathematically as L is equal to phi over I. Thank you for your time and attention. If you would like to challenge yourself, please answer this question in the comments below. Challenge number 25. Sine and cosine waves are fundamental periodic waveforms that can be used to construct any complex wave shape through a process called Fourier analysis. What is a Fourier series?